Biomedical engineering, a fascinating interdisciplinary field, integrates the principles of engineering with the life sciences to create innovations that improve healthcare and quality of life. Biomedical engineers work at the intersection of biology, medicine, and engineering, applying their expertise to develop technologies, devices, and systems that address complex medical challenges. Among the prominent academic pathways in this discipline, a Bachelor of Biomedical Engineering (BME) program stands out for its comprehensive approach to training students in both theoretical and practical aspects of the field. In particular, the BME X2 program, a more specialized and intensive version of traditional BME studies, has garnered attention for its ability to produce graduates who are not only technically proficient but also industry-ready. This program equips students with a robust foundation in biomedical engineering concepts while fostering the critical thinking and problem-solving skills essential for tackling real-world challenges. The BME X2 program is designed to meet the demands of a rapidly evolving field where advancements in technology and medicine are reshaping healthcare delivery. The curriculum integrates fundamental engineering principles with biological and medical sciences, creating a strong foundation for innovation. Students are introduced to key areas such as biomechanics, bioinstrumentation, medical imaging, biomaterials, and systems biology. The unique aspect of the BME X2 program lies in its emphasis on research, hands-on experience, and multidisciplinary collaboration. Unlike traditional programs, BME X2 emphasizes an accelerated learning model, enabling students to delve deeper into specialized areas and gain exposure to cutting-edge developments. A cornerstone of the BME X2 program is its focus on experiential learning. Students participate in laboratory work, internships, and industry partnerships that provide real-world exposure to biomedical challenges. This hands-on experience is invaluable in developing practical skills and understanding the complexities of biomedical systems. Laboratories equipped with state-of-the-art technology allow students to experiment with designing and testing biomedical devices, such as prosthetics, diagnostic equipment, and drug delivery systems. Internships at hospitals, research institutions, and biomedical companies further enhance their ability to bridge the gap between academic knowledge and practical application. The interdisciplinary nature of biomedical engineering means that students must acquire expertise in various domains. In the BME X2 program, courses are structured to ensure a balance between engineering fundamentals and life sciences. Topics such as fluid mechanics, thermodynamics, signal processing, and control systems are integrated with anatomy, physiology, molecular biology, and biochemistry. This holistic approach ensures that graduates are well versed in the language of both engineers and medical professionals. Additionally, the program incorporates emerging fields such as artificial intelligence, AI, machine learning, and robotics, which are revolutionizing healthcare delivery. By understanding these technologies, students are prepared to contribute to advancements in areas such as precision medicine, surgical robotics, and personalized healthcare. A critical element of the BME X2 program is its emphasis on innovation and entrepreneurship. Students are encouraged to think creatively and develop solutions to pressing healthcare challenges. Many programs include a capstone project or senior design project where students work in teams to design, prototype, and test biomedical devices or systems. These projects often address real-world problems identified through collaborations with healthcare professionals or industry partners. The entrepreneurial aspect of the program equips students with the skills to commercialize their innovations, transforming academic ideas into market-ready products. This focus on innovation aligns with the broader goal of biomedical engineering, to improve patient care and enhance quality of life. The role of research in the BME X2 program cannot be overstated. Research opportunities enable students to explore cutting-edge topics and contribute to scientific advancements. Faculty members, who are often leaders in their respective fields, guide students in conducting experiments, analyzing data, and publishing findings. Research areas in biomedical engineering are diverse, ranging from tissue engineering and regenerative medicine to nanotechnology and biosensors. By engaging in research, students gain a deeper understanding of the scientific process and develop critical skills in inquiry, analysis, and communication. This experience is particularly valuable for those pursuing advanced degrees or careers in academia and research. Collaboration is another defining feature of the BME X2 program. Biomedical engineering inherently involves working with professionals from various disciplines, including doctors, biologists, chemists, and software engineers. The program fosters teamwork and communication skills by incorporating group projects, interdisciplinary courses, and collaborative research initiatives. This collaborative approach mirrors the professional environment of biomedical engineering, where complex problems often require input from diverse perspectives. Through collaboration, students learn to navigate challenges, synthesize information, and develop innovative solutions that address multifaceted healthcare issues. The global impact of biomedical engineering is evident in the transformative technologies and therapies it has produced. From advanced imaging systems that enable early disease detection to life-saving medical devices such as pacemakers and artificial organs, biomedical engineers have revolutionized healthcare. The BME X2 program prepares students to contribute to this legacy by instilling a strong sense of social responsibility and ethical awareness. Students are taught to consider the broader implications of their work, including issues of accessibility, affordability, and sustainability. By understanding the societal context of biomedical engineering, graduates are better equipped to create technologies that benefit diverse populations and address global health disparities. Another advantage of the BME X2 program is its adaptability to individual interests and career goals. Students have the flexibility to choose electives or pursue concentrations in areas such as neuroengineering, cardiovascular engineering, or biomedical informatics. This customization allows students to tailor their education to align with their passions and aspirations. Furthermore, the program often includes mentorship opportunities, where students receive guidance from experienced professionals who can help them navigate their academic and career paths. This personalized approach ensures that graduates are not only knowledgeable but also confident in their ability to make meaningful contributions to the field. The BME X2 program also emphasizes the importance of lifelong learning. As technology and medicine continue to evolve, biomedical engineers must stay abreast of new developments and acquire new skills. The program instills a mindset of continuous learning and adaptability, preparing students for a dynamic and ever-changing field. Graduates are encouraged to pursue professional certifications, attend conferences, and engage in networking opportunities to remain at the forefront of biomedical engineering innovation. In terms of career prospects, the BME X2 program offers a wealth of opportunities. Biomedical engineers are in high demand across various sectors, including medical device companies, pharmaceutical firms, research institutions, and healthcare organizations. The program's rigorous training and practical experience make graduates highly competitive in the job market. Additionally, many alumni choose to further their education through master's or doctoral programs, opening doors to advanced research, academia, and leadership positions. The versatility of a biomedical engineering degree ensures that graduates can pursue diverse career paths and make significant contributions to society. The BME X2 program represents a paradigm shift in biomedical engineering education. By combining a robust curriculum, experiential learning, interdisciplinary collaboration, and a focus on innovation, the program equips students with the skills and knowledge needed to excel in a challenging and rewarding field. Graduates of the program emerge as well-rounded professionals who are not only capable of addressing current healthcare challenges but also poised to drive future advancements. As biomedical engineering continues to evolve, programs like BME X2 play a crucial role in shaping the next generation of innovators, researchers, and leaders who will transform healthcare and improve lives.